Hi everyone, welcome to this lesson. In this lesson, I'm gonna talk about the one-dimensional motion. As you see here, one-dimensional motion. And firstly, let me explain something about the motion. Motion occupies a lot of space in our daily life and in everywhere. It is sometimes visible, sometimes invisible. With our naked eye, we cannot see it. I'm gonna give you two examples. Maybe you know these examples. As you know, first one is the electron, and second one is the Earth. As you know, electron rotate around the nucleus. Electron rotate around the nucleus, turn around the nucleus, and it's rotate around itself. So electron, if we look at it, it is spinning around itself, and it is turning around nucleus. And there is a similarity between electron and the rotation of the Earth. If we draw the Earth like this, if it is Earth, the Earth turn around itself, or it's rotating around itself. If we put here Sun, also at the same time, Earth revolving around the Sun. So there is a similarity between motion of the electron and the motion of the Earth, we can say. And also, if we take the motion of the Earth or motion of the galaxy, all the galaxy, there are many planets in our galaxy, as you know, and all of them is rotating. They are turning around itself. They are turning around center of the Sun. So, another example I can give you, if we have a bunch of iron, let's say, when we put it somewhere, it is stable. If you don't apply the force on it, if you don't try to push it, it does not move. But if you push it, if you apply the force on it, this iron can move. If you look at the element or atom of the iron, actually they are moving. Inside of it, there is an electron, nucleus, and inside of this atom, that electron is revolving. Also, there is another type of motion. Every particle has motion. What does it mean? Also, they are vibrating. But this vibration, with our naked eye or with our bare hand, we cannot observe it. We need some kind of device. Now, I'm going to talk about the displacement and the velocity. And before it, we have to discuss about the one-dimensional motion. So, in the previous part, we discussed about what is the motion. There are types of motion, but this is not in this part of the book. And here we are going to talk about the one-dimensional motion. One-dimensional motion, simply you can understand from its name, we have one dimension. And our motion must be in one direction. For example, if you have a straight line, if the object moving on it in the one direction without turning anywhere, it is called one-dimensional motion. Like this path on the screen, on the picture, as you see here, if you move straight, that means you are moving on one direction. For example, if you draw the direction north, south, east and west, this car now, if it is moving in this direction, that means it is moving in direction of the east. So this types of motion called one-dimensional motion. If it is moving in this direction, it's moving north. If it is moving in this direction, it's moving to the west. These are called all one-dimensional motion. Simple one-dimensional motion, the motion only in one direction. Yes guys, in this video simulation, we will talk about the one-dimensional motion. Now I will apply the force to this block and it will move in one dimension. As you see, according to us, it's moving in the right direction. So we call this kind of motion one-dimensional motion. Now I'm going to talk about the frame of reference. Here there is an explanation, a coordinate system or specifying the precise location of object in space. What does it mean? I will explain to you. As you know, at the beginning of the chapter, I explained the motion of the Earth and the motion of the electron. Electron turn around the nucleus and the Earth turn around the Sun and it's turn around itself. Also our galaxy, all of them together, they are turning around the center of the Sun. They are revolving. So there are many kinds of motion on the Earth, we can say. If you look at this picture, the first guy says it's 6 and the second guy says it is 9. Which one is true? Which one you can pick true answer? You can say both, of course. Because first guy's reference frame, it looks like 6. And the second guy's reference frame, it looks like 9. And now I will give you relation frame reference with the motion. For example, let's say there is a bus here. I can't draw very well, sorry for that. Let's say there is a bus here. And inside of the bus, we have passengers. First passenger, second passenger. And let's say this bus is moving in the direction of the west with the 50 kilometer per hour. And out of the bus, let's say this is the bus. Out of the bus, we have another guy, which is the third guy. And third guy is stable. That means not moving. And when the third guy look at the first and second guy, third guy gonna see first and the second guy moving in the west direction with the 50 kilometers per hour due to third guy, third, or also we can say third observer. But if the first guy look at the second guy, the first guy gonna observe second guy. If the second guy does not moving in his own place, second guy gonna see the first guy, or first guy gonna see the second guy. They are not moving because both of them moving with the velocity of 50 kilometer per hour. That means they are moving with the same velocity of the bus. The bus velocity must be equal velocity of the any part in it. First guy's velocity due to second guy, it is 0. Or second guy's velocity due to first guy, it is 0 again. So we call that reference frame. According to your reference, the information can change. Like in this picture, according to first guy, it is 6. According to second guy, it is 9. So here we have a 1, 2, 3 guys. So when the first guy observes the second guy, he's gonna see the second guy is not moving, but they are moving both together. But when the third guy observes the first and second guy, the third guy gonna see both of them moving with the 50 kilometer per hour. Or one more information I'm gonna tell you. If the first guy observed the third guy, what will happen? If the first guy observe the third guy, what will happen? The first guy gonna see the third guy. The third guy is moving in the east direction with the 50 km per hour. Because always we accept observer is stable. Now I'm gonna talk about the displacement. Displacement, word of the displacement, it's similar as the distance. Similar as the distance, but the displacement and distance completely different than each other. In this lesson, you're gonna learn it. And in the physics, actually in the science, some words in a daily life, they are similar, but in the science, they are very unique and very different than each other. They mean much more different things. And here, I'm going to talk about the displacement. Before talking about displacement, I want to tell you something. For example, we have one guy. That guy is moving in this direction 4 meters. And in this direction, he's walking 3 meters, let's say. What is the displacement of this guy? This is the starting point. This is the final point, initial point, and the final point, and the initial point. And what's the displacement of this guy? This guy. I can hear your answer. Most of you say it is 7 meters, isn't it? But it is not 7 meters because I'm not asking you distance. I'm asking you displacement. Displacement is completely different than the distance. So let's see the now definition of the displacement and let's answer this question again. Smallest directional distance from starting point to final point of the motion. And if we look at the motion, this is the initial point and this is the final point. So what is the smallest directional distance? First point and the second point. What is the smallest directional distance between first point and the second point? This one? This one? No, none of them. It must be completely straight line. So between 2 points, the shortest distance is the straight line. We can say like this. And on the plane we can say. And shortest distance between initial point and the final point of the path is this straight line from initial point to final point. So this line is our displacement. So according to Pythagorean theorem, when you calculate this, it is the 5 meters, I can say. So here displacement is 5 meters. It is completely different than the distance. Now I think we got it. So this is important. Displacement from starting point to final point, and it is directional. Directional means we can say straight line. That is called displacement. Keep it in your mind. It's very important for the other chapters and the next year subjects. Now I'm going to talk about the position vector. In the next page we will need it, and it is a little bit related with the displacement. Position vector has magnitude called distance and direction relative to the reference point. What does the mean of the reference point? For example, when you are describing your address to your friend, you are saying it is near to this building, behind the market, or in front of the this company, like this. So when we are describing our address, actually when we are describing the position of our address, we are giving some reference point. So position vector means your position according to some relative or reference point, we can say. For example, if we draw a 3, let's say. Let's keep this in your mind. It's a 3. And the guy standing here, when you look at the 3, or when you explain the position of the guy, let's draw here a building, apartment, let's say. You can say it is the right side of the 3 and the left side of the building, or the guy standing at between 3 and the building. So here I gave you reference point. One of my reference point is the 3. One of my reference point is the building. So this one called position. Now I will tell you one more thing about the displacement part. If you start your motion from here, and if you walk any crazy path like this, and if you return the same point again, so what is the displacement here now? Important question. It says displacement is the smallest directional distance. If initial point and final point same, your displacement is 0. Keep this in your mind. If your final point and the initial point, it is the same point, it is 0 displacement. But it doesn't mean 0 distance. I can explain it another page. Displacement again. I explained what is the displacement here. So displacement is the smallest and directional distance. Now we're gonna take another definition of the displacement. So displacement has 2 definitions. In the exam, if you have writing question about the definition of the displacement, you can write one of it. So this definition of the displacement is change in the position of an object. So change in the position of an object. Now you know what is the position because previously we discussed about it. And here you can imagine the guy moving on a straight line, we can say. This point is the x0 is the initial point. Here we have 2 more points. And what is the displacement? Change in the position of an object. In our calculation, in our question, we're gonna focus on most of the times one-dimensional motion because chapter is the one-dimensional motion. So the motion gonna be on a straight line. We have formula about the displacement. The symbol of the displacement in the formula, delta x. Delta represents here change. So what does the mean of change? Final position, x final position minus initial position. So delta x is the displacement. X final means final position. X initial means initial position, we can say. So if we consider first position of the object or the guy is 0 and the final position, let's accept this is the final position of the guy, it is 5 meters. So we can say 5 minus 0. So displacement of the guy, it is 5 meter, we can say clearly. And the unit of displacement is meter. So this is the second definition of the displacement. and this is the formula of the displacement. We can say you have to keep it in your mind. In the exam you are gonna use it. Delta x equals x final minus x initial. You have to keep this formula into your mind. And here we are gonna discuss about important point. It says displacement is not always equal to distance traveled. So it's a bit amazing part, because when we look at the displacement and when we talk about the distance in our daily vocabulary, they look like very similar to each other. But here it is very different than each other, because we are in the physics lesson. And there is a turtle. Starting point of the turtle is this point, point P, and the final point of the turtle, it is the point R. And while walking from starting point to final point, the turtle following this green line. This green line. So it starts from P and it will reach to R. And now we will check the distance and the displacement here. Which one is distance? Which one is displacement? If you remember the definition of the displacement, what is displacement? Directional. It was saying directional. So it must be line or arrow from initial point to the final point. So initial point is this point, initial point, this point is the final point. So this red line is, or red arrow is our displacement. And this green line which turtle follows to reach from point P to point R, it is the distance. Now in this picture, distance equal displacement. Can you answer me? Of course you cannot answer. This is the recorded lesson. I will answer myself. So here it's clearly you can tell me this red line is not equal to the green line. It is very visible for us. So here displacement is not equal to distance. For example, the green line, let's say 10 meters, and the red line, let's say 5 meters. I gave you numbers roughly. So they are not equal to each other. They are not always equal each other. In some cases, they are equal each other. In which case they are equal each other? If the walking is the straight, they can be sometimes equal each other. But the displacement and the distance, they are very different than each other. So keep this in your mind. You can face these types of questions in the exam.